This is in continuation to a previous video whose link I will be sharing in the description. In this one we will see how does it affect the graph when we cross the frequency by half mark. That is, if we increase the frequency by half. So let's see first what happens when it is exactly equal to half. So see, for half the graph becomes straight, because you can see that now the equation is 2 pi f, and f is 0.5, so it's 1 pi, and that is always a constant number. So the graph is a DC kind of, you can say. Now what happens when we go past 0.5? Let's say 0.51, or increase it by a very small amount, 0.05, so it becomes 0.505. So to know what exactly is happening here, first let me reduce the sampling time. Increase the sampling time. So we have like this vector. You can choose an odd number like this. You can find out, as you can guess in the comment, why odd works and even doesn't. I'll give a hint. Odd plus odd is even. So when you keep on adding odd sampling time, once you get odd, next time you get even. Well, for even sampling time, you always get even numbers. So based on the equation that I'm going to explain now, and this information that I gave, the odd plus odd and even plus even thing, you may guess why even sampling time doesn't show the clear picture in this case. So see, two cases are there. Case 1, frequency is greater than 0 and less than half, and second case, greater than -1/2 and less than 0. So both will be almost similar. I will show for this one, this case 1. You can try for the case 2. So let's say we have equation x of n equal to cos 2 pi fn, and we increase the frequency by half, that is half plus f. So since f is in this range 0 and within half, so we are adding something lesser than half to half. So if we expand the equation, this will become pi n plus 2 pi fn, and then this expansion of cos a plus b. So sin pi n is 0, so the second part will completely become 0. So it becomes cos pi n cos 2 pi fn. Now cos pi n, this is this can take value -1 or 1 depending on it, because cos pi for odd multiple of pi is always negative, and even multiple of pi is always positive. So we can also write this equation like this: -1 to the power n cos 2 pi fn, and this was the x of n. So see, we can see the equation. If we add half to a frequency, it is actually -1 to the power n of the previous graph. So for example, in this case we are doing 0.505. So in terms of this equation, we can express it as half plus 0.05. So this equation should be actually the graph of equation 0.05, but for alternate samples it will take reverse sign. What does I mean by that? I will explain. See, for example, I make it back to 0.05. So now this is the graph of 0.05. So what does adding half to it will do? So suppose the first sample is this one, second sample is this one. So if we add half, the second samples we have the reverse of that, means negative of that. That's why what we are seeing, the result is one pointing up while one pointing down. So we'll make it back to 0.505, and we see one sample is down, another is up, next is down, this is up. That's why this kind of graph. Now we have, okay, so we have one more case to see, one more phenomenon to see, that is aliasing. What is aliasing? By aliasing we mean that when we are doing this kind of plotting of this kind of graph where the frequency is more than half, so it is actually basically one of the graph of frequency less than half, means 0 to 1 by 2. So it is said that what any graph above half is alias of some or the other graph in between 0 and half. See how it can be proved. So let's say we'll decrease half by f. So we have this kind of equation, 2 pi half minus f. That means earlier we were adding half to the current frequency, now from half we are subtracting any frequency which is within 0 and 1 by 2. So this equation expands to the same whatever we saw above, because cos a minus b is cos a cos b plus sin a sin b, and we saw in the above case the sine part got completely zeroed. So in this case also this second part will be 0 and first part remains the same irrespective of this sign. So we saw that if from half, if we reduce the frequency, it comes the same graph if we add half to it. So we can say that half minus f frequency, no, I mean half plus f frequency is the alias of half minus f. So to see this, see this graph with frequency 0.505 has frequency more than half. Now what will be the alias of it within 0 and half? We need to reduce the same thing from half. So 0.05 subtracted to half is 0.495. So if I do it 495, so we get the same graph. This is it. So now if you have guessed this part, why sample 11 shows it correct while 10 doesn't? Because as I told, even samples will always turn into even, and if you put that thing, wait, bring that picture up again. So for every multiple of 10 we have this n as even, so every time we will be seeing the half picture of the graph, that is only on the even side when n is even. That's why we are seeing the graph that we are seeing is not correct. So for a graph of this kind we must always use an odd sampling time. For example 1, or we can use 7. So let me know in the comments if you have any doubt related to this video.